Okay, you actually do not have these pictures in your notes. I just wanted to let you think about how to take measurements before we start the next part of this chapter. So if you had a beaker that looked like this, and I asked you how much liquid is in the beaker, I think that'd be pretty hard to tell me, because the only number you see there is the 100 milliliters. So maybe you could estimate that as maybe 60 milliliters, so this is not a good way to measure. But if you get a little more specific, you start to see the lines on here. So maybe you could count 1, 2, 3, 4, 5, 6, maybe 67 milliliters is a better estimate. And then how about this? You can see between 60 and 70 we have 10 lines. And actually, if you look at this line up here, that's 1, 2, 3, 4, 5, 6, 7, and the blue seems to be a little bit past that. So maybe 67, now you can add a decimal, maybe 0.1 or 0.2, so even more specific. Okay, what I'm trying to show you is when you take measurements, there is a degree of uncertainty. And when you know what's called significant figures, you can eliminate that uncertainty. So there are 3 rules listed here, and I'm not going to go through these. There's no point to just reading them. I think it helps if you just look at examples, and these will explain the rules, but they are here for you. Okay, the number 211. Why 3SF means significant figures. Why are there 3 significant figures? Because any number that's not a 0 is considered important or significant. So all 3 of these count. In the next example, it says 201, and I still see 3 significant figures. The problem now is a 0, and the 0 is what affects the different rules. This 0 is in between numbers, and I like to call it sandwiched. Any sandwiched 0 is considered significant. So all 3 of these numbers count. But look at the next example, 210. Why are there only 2 significant figures? The reason is any 0 at the end of a number, and there's no decimal point, is considered insignificant. The reason is you could put this into scientific notation. That would become 2.1 times 10 to the second. So because of that, you eliminate the 0. So that is the reason for that rule. But if you look at the next example, 21.0, there you have 3 significant figures because you have a decimal point, so that 0 counts. And in my last example, the answer is not showing up on my video here, but you will hear me say it. 0.021 has 2 significant figures. That 0, I know it's after a decimal, but it's before the number. That is considered insignificant. It does not count. And again, the reason is you could put that into scientific notation. It would become 2.1 times 10 to the negative second. That is the reason why. Alright, so not only do you have to identify significant figures, you have to use them. So here you can see the rules for addition and subtraction. It's going to involve a decimal, but I think it's better to go through an example. Multiplication is not the decimal, it's total significant figures, which you can use a lot in lab, but the best way to do this is through examples. So watch. So check out this. If you plug 42.7 plus 35.36 into your calculator, actually I would do this right now, 42.7 plus 35.63. The answer in the calculator is 78.33. Why do I only have 78.3? The reason is when you add or subtract, your answer should match the least decimal place. So in 42.7, the 0.7 is 1 decimal place. In 35.63, the 0.63 is 2 decimal places. 2 versus 1 means that 1 is smaller, and I should only have 1 in my answer. So 78.33 becomes 78.3. In the next example, if you plug in 355.09 minus 34.2 on the calculator, you get 319.89. Why do I have 0.9? Again, 2 decimal places, the 0.09, 1 decimal place for the 0.2. You need to round your answer, we'll talk about rounding in a second, to 1 decimal place. Okay, and if you have more than 1 number, it's fine. 12.11 plus 18.0 plus 1.013. In my calculator, it's reading 31.123. Why is my answer, if you can see it, is 31.1? The reason is 2 decimal places in 0.11, 1 decimal place in 0.0, and 3 decimal places in 0.013. So the least amount is 1 decimal place, so you need to round that to 31.1. So adding and subtracting is based on the place of the decimal. Multiplying and dividing is not. If you take this first example, 4.56 times 1.4, the answer in the calculator is 6.384. Now it looks like this is following the rules for decimal places, but it's not. Why did I round it to 6.4? It's total significant figures. So in 4.56, there's 3 figures. In 1.4, there's 2 figures. So your answer should match the least amount of significant figures. So you round it to 6.4. Good example is the next one. If you are following me, please plug this into your calculator and see what you get. I have a huge answer, 0.0279026846. And a lot of you will write that on your answers in the lab. And I don't know why, it's a lot of work, so I'm trying to teach you how to shorten that up. Why is my answer 0.0279? Well, it's total significant figures. 4 in my first value, 3 in my second value, so my answer has 3 significant figures. Those zeros do not count. Alright, and let's just practice rounding, okay? 1.33, if you round it to 2 significant figures, becomes 1.3. Anything less than 5 does not change the number you are attempting to round. So the 3 stay the same. 1.36, 6 is greater than 5, so it affects that 3 and makes it round up to 1.4. And then in my last example, this is kind of like a domino effect. I want 3 significant figures. The 7 is greater than 5, so it rounds the 4 up. 4 is now 5, and that rounds the 3 up, so this final answer is 6.84. That's 3 significant figures.